Okay. Yeah, I think, so let's hold off on lab problem 6. Don't do that now. What we're going to do is we'll go over that next class, but I think what people really want to do now is we should go over this and make sure people really understand it. So the first question someone had was, how do we know that it's one-tailed? And you have to figure out what the claim is. So since this claim is that they are greater than, then that means that your claim is greater than. That the first mean is greater than the second mean. Is everyone kind of following me? So find the claim and figure out whether it says greater than, less than, or is or isn't, or same or differs, right? All those different words, exceeds, decreases. Those are all the kind of words that can make it, greater than or less than or not equal to or equal to. So find the claim and figure out what it's claiming. So this one's claiming it's greater than, so it's going to be one-tailed larger than. And then subtract them, right? Take the top one, subtract the bottom one. Figure out whichever one you want to be, you have to be the top one, subtract the bottom one. And then you've got these guys here. And then we're going to throw those into a calculator, into a list, and do calc 1 bar stats on them to find your x bar and your s. So again, my claim is that it's greater than, so the differences are greater than 0, so it's going to be, right, greater than 0, or it might not even be, I might not say greater than 0. If I say the presidents are greater than their opponents, then that would be greater than 0. Right, because we'd say that the mu1 is greater than mu2, so the differences would be greater than 0. So here you can write it here, mu d equals 0, and that's my claim is greater than, so my claim would be mu d is greater than 0. Sorry, I think I pulled the wrong one.
So,
yeah.
If it doesn't give you, like, a specific number, how do you, like, what is the symbolism for that? Like, what do you write for that?
Right, because remember, this is, I can draw it. Oh, maybe I can text it. Remember, this is always that mu 1 is greater than mu 2, right? But the same thing as saying that this means that mu 1 minus mu 2 is greater than 0. So it comes from that. Do you guys remember we've kind of looked at all along the idea of looking at these, here, I'll try to, oops, of looking at of these guys here, P1 minus P2 is equal to 0, right? So we've written them before like this. You guys understand what I'm saying? Before we've written them like this. But you could also have written it like this, P1 minus P2 equals 0. Does everybody get that? These mean the same thing. Because if they're equal, if you subtract them, you should get 0. No difference. The thing about this one is, I'm not going to have the P1 and P2 anymore, the mu1 and mu2, because I'm going to subtract them individually, and all I'm left with is one number, the difference. So what I'm going to end up with is this right here, P1 minus P2, already subtracted kind of individually, the little individual guys, which means that I have to go with their differences are greater than 0. So this one has to be that their differences, mu1 minus mu2, is equal to 0. I can't have mu1 is equal to mu2 anymore. I have to say the difference is equal to 0, because that's what I found are these little small d's. I no longer have these numbers and those numbers. Why? Because it's dependent. Because it's dependent, we're just going to subtract them, and then all we have is just these numbers here. That's what we're left with. So we can't talk about the mu1s and the mu2s anymore, because we're only talking about the differences. So that means we can't use that. So instead, what we're going to have is this here, mu1 minus mu2. Since mu1 is greater than mu2, then mu1 minus mu2 has to be larger than 0. If it was the other way around, if mu1 was less than mu2, then mu1 minus mu2 would be less than 0. These symbols are going to be the same always. If mu1 is greater than mu2, then the difference is going to be greater than 0. If it was mu1 is less than mu2, then the difference would be less than 0. If these two are equal, then this difference would be equal to 0. You guys sort of understand what I'm saying? So since we're playing...
If it gives you a specific number, like other than 0 centimeters,
it can't for
would
this.
you then repeat that?
For a difference between, for a dependent difference, it can't. It won't do that. I will always, it's theoretically possible, but it happens very rarely. So I'm always going to give you 0 here.
Got it. Thank you.
Yep. But remember, that's only for dependent. Do not take that 0 and start using it all over the place in Chapter 8, because it does not belong in Chapter 8. Chapter 8 is going to be 84 or 13.6 or whatever, whatever the claim is. Has everybody got that? This 0 only applies for dependent 9.4 only. Okay. So here we're saying that this difference is equal to 0, and then H1 would be that the difference is greater than 0. I think we got as far as, okay, so then did people understand this degrees of freedom part where we got degrees of freedom of 4? It came from the fact that we had have 5, our little D's here, we have 5 D's here, so our N is 5. So because our N is 5, our degrees of freedom is going to be 5 minus 1, because we only have one variable, which is height. Everybody okay with that part? And you guys understand why this is one-tailed? Because of that greater than?
Yes.
Okay, good. So the greater than makes it right-tailed, one-tailed. So when we look it up on the t-table, it's going to be one-tailed greater than 0.05, and then we're going to drop down to the fourth degrees of freedom 4, 2.132. Everybody good with the shading part and the labeling part? Ask me questions. This is a great time to ask me questions. If whatever question comes to mind, because we want to make sure that people are really good with this. Test stat. Again, you found these from doing stat calc 1-bar stats. And just kind of pop everything in there. Remember, whatever this one is, this mu always, always, always comes from your claim. Always. And your x bar here always, always, always comes from your statistic, from your sample, whatever your sample was. Right? It's a statistic. It's your sample mean. So whatever your sample gave you, that's where this one comes from. This one comes from the claim. And my claim was 0, right? Was that, this is what mu is here. Yeah.
For standard deviation, it's only one decimal place.
Yes. Yeah. Yeah, and that's good. So you can use, yeah, that's fine. If you use 1 or 2, that's okay. I don't care. I'm going to be fine with whether you use 1 or 2.
Okay.
Yeah.
So how do you calculate the degrees of freedom if we're not going to use it?
What do you mean? You have to use it. You use the degrees of freedom in the t-table.
Oh, okay. Never mind.
Yeah. So yeah, the degrees of freedom this comes into play with your t-table. So yeah, I know this is here, but it really belongs here. I should have put an arrow up to there. Thank you. That's a good question. Thanks. Questions? More questions? I want to make sure you guys get this. Okay, is everybody good with rejecting, not rejecting H naught because it's in this area here? This is my not guilty, do not reject. This red zone over here, this is the guilty, enough evidence, reject H naught. You have something unusual. If you have something unusual, you reject H naught. H naught says I'm over here. If I'm anywhere along here, then yeah, I could be here. But if I'm way out here, then I am not here. Does that make sense? I've got to be something closer to the right if I get a sample way out there. Okay. And is everybody good with this? Is everybody good with this? These two matching up? It's either do not reject and not enough evidence, or the knots could both go away, but they're either both going to be there or both not going to be there. Yes, no? Okay, good. All right, perfect. And then, do we clarify the support part here, or do you guys want me to talk about that yet again? I'm sorry, I don't want to bore people. And then make sure you do have to say what the claim is, and the claim is just verbatim. Don't change the claim. You can't change the claim. You can't say they're, reject and something else and same. You can't change this. It's whatever the claim was, right? This has to be whatever they have said the claim is to be. Okay, good. I want to talk a little bit now, the last few minutes we have, about the project, part 5. So one thing I want you guys to know is that YouTube, if you go to YouTube in my playlist, go to project, and in project, I have, you can see them right here. So this is my playlist. This isn't my playlist, sorry. This is, if you go to project in my playlist, it's one of my playlists, and has all of the project videos. There's 2. This is the one that are in here. And you should skip minutes 2 to 3:30 since we're not printing. That's all about how to print it. And since you're not printing it anymore, you're just going to email me your Excel file or email me the link to your Google Sheets. Then you have to do that one. So here's the first part. First of all, it's just your quantitative questions, your 2 numerical questions. So the quantitative numerical questions are the 2 we're working with on this part, and you're going to find the average of them. You're going to find the mean and bring it up. You're going to find the median, the mode, standard deviation, and then you're going to round that to 1 decimal place, and just round it using rounding rules. And then quartiles, you'll find those as well. And remember the IQR is Q3 minus Q1, so you're going to need to find that also. These pages here, pages I think 3 and 4, you don't need. They're all about printing, so you can skip those pages entirely. And then the last 2 pages are things you need to fill out. So these last 2 pages, you need to fill those out, take pictures of them with your camera, and email me those pictures. So I need pictures of these last 2 pages, emailed to me, and your Excel sheet. So here you're going to write in whatever your variable is, like inches, height in inches, and this might be number of family members, and then write down what the IQR is for each of those. Then multiply each of those numbers by 1.5 to get 1.5 IQRs. I talked about this more. I talked about this in the video. Actually, I kind of talked about, finding, finding the lower limit of outliers, upper limit for outliers, and physical listing if there are any. And then the last part, the rest of it is only going to work with 1 variable. You're only going to use 1 variable for this part, the last part. The one that you use to make the frequency polygon in the ogive in part 3, project part 3. Write down the name of that variable, what the rounded mean was, and what the rounded standard deviation is. And then you're going to find these upper and lower limits for within 1 standard deviation, within 2 standard deviations, within 3 standard deviations. And I talked about that in the video already as well, so I don't really want to go through that part. But Chebyshevs, what you're going to do is you're going to count how many are in each of those ranges, right? And maybe this is impossible. But say I got 112 of them that were in that range, then the percent would be 112 out of the total, 72.7%. Right, and then to say, does that match up with Chebyshev theory, which says it has to be at least 75%? And no, it doesn't, because it's not at least 75%. So this is actually impossible. This wouldn't have happened in real life, because Chebyshev's is dead on accurate. It has to be at least 75%. It can be more, it can be 90%, but it has to be at least 75%. And is this one at least 89%? And then say why or why not? And say, in this case, I'd say no, because it's only 72.7%, so it's impossible, even though Chebyshev says it must be at least 75. But yours should definitely match up. And then the empirical rule, right? So the empirical rule says it should be about 68% within one standard deviation, about 95% here, and about 99.7% here. So you have to figure out how many are within 3 standard deviations, and if that matches up or not. Are you getting about 68 and 95% and 99%, 99.7%, or maybe you aren't. And then the last part, last couple parts are you don't have to do a histogram. So no histogram necessary. You can just use your frequency polygon and see if you think that your data looks like it's normal, left skewed, or right skewed, or something else. And then this part up here, seeing if your mean and median are about the same, or if the mean is lower or the mean is higher. So circle which one it is, and then based upon this, does that mean that it should be about normal, or should be right skewed or left skewed, depending upon what you answered here. All right, remember look through your notes. If the mean is lower, then that means it's left skewed. If the mean is higher, then that means it's right skewed. All right, yep. Mean is higher than the median. Mean is higher than the median. Yep. That means it's right skewed. Okay. So that's it. So just take 2 pictures of those and send them in to me. Had a great day. Any other questions before I call this meeting over?
Professor Young,
Yeah.
in Canada it says that we have to submit page 28.
Oh, I just changed that. I thought I just changed that an hour ago to 2 hours ago to say page 27.
Okay. So it's page 27.
Yeah.
What we just did.
Yeah. The one you just did, page 27, is the one you should submit on Canvas by tomorrow. So the one we just finished, page 27, is the one you guys need to be submitting.
Along with the quiz.
Along with the quiz, yeah, for sure, the quiz. Good. All right, any other questions? We're good? All right.